Alright, let's look at how we can solve this problem on the board. If 124 in base n is equal to 232 in base 5, find the value of n. In this problem, the first thing to do is to convert the left hand side into base 10 and also convert the right hand side into base 10 before comparing the equation. For instance, if we have A, B, C, and D all in base W, to convert this into base 10, we multiply each of the numbers or each of the terms by the base, which is the little numbers written under. Therefore, we have A times W plus B times W plus C times W plus D times W. After this, we start with the last number written. Starting from 0, we count toward the left hand side. That is to say, W raised to the power of 0, W raised to the power of 1, raised to the power of 2, raised to the power of 3. Alright, so we have A, W raised to the power of 3 plus B, W raised to the power of 2 plus C, W raised to the power of 1 and plus D, W raised to the power of 0. Alright, let's bring this knowledge into the left hand side. So let's analyze the left hand side. In the left hand side, we have 1, 2, 4 in base n. To convert 1 to 4 in base n into base 10, it becomes 1 times n plus 2 times n plus 4 times n. Counting from 0, 1, 2 towards the left hand side. Then we have 1 times n raised to the power of 2 is n raised to the power of 2 plus 2 times n raised to the power of 1 is 2 n plus 4 times n raised to the power of 0. N raised to the power of 0 is 1 and 1 times 4 gives 4. Therefore, we have n raised to the power of 2 plus 2n plus 4. Alright, so we have, bringing this to the left hand side, we have n raised to the power of 2 plus 2n plus 4 equal to, let's do the same thing to the right hand side. In the right hand side, we have 2, 3, 2 in base 5. To convert this into base 10, it becomes 2 times 5 plus 3 times 5 plus 2 times 5 raised to the power of 0, 1 and 2. Alright, so 2 times 5 raised to the power of 2 is basically 2 times 25. 5 raised to the power of 2 is 25, and we have 2 times 25 plus 5 raised to the power of 1 is 5, and 3 times 5 gives 15 plus 5 raised to the power of 0 is 1, anything raised to the power of 0 is 1, then 2 times 1 gives 2. Alright, so we have 25 times 2 is 50 plus 15 plus 2. 50 plus 15 is 65, and 65 plus 2 is 67. Therefore, at the right hand side, we obtain 67, which becomes 67. Okay, we can compare these two equations by collecting like terms. That becomes n raised to the power of 2 plus 2n equal to 67 minus 4. And we have n raised to the power of 2 plus 2n is equal to 63. This is our quadratic equation. So you can solve n raised to the power of 2 plus 2n plus 63 as a quadratic equation, either using a factorization method or using a completing the square method. We can as well use a formula method, which is the almighty formula. So since this is a quadratic equation, let's equate it to 0. Therefore, we have n raised to the power of 2 plus 2n minus 63. When it crosses over, becomes minus, this is equal to 0. Okay, let's solve this using the almighty formula or the formula method. In the formula method, we have to determine the value of a, b, and c in the equation. So in this equation, a is equal to 1, the coefficient of n squared is 1, and b is equal to 2, b equal to 2, then c equals minus 63. Minus 63. Now, at this juncture, we have to apply the almighty formula or the formula method in quadratic equation. The formula method is given as n is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Alright, let's substitute. N is equal to, my b is 2, therefore minus 2 plus or minus square root of 2 raised to the power of 2 minus 4 times a is 1, so 4 times 1 times c, and c is minus 63 all over 2 times a, which is 1. Therefore, n equals minus 2 plus or minus square root of 2 raised to the power of 2 is 4 minus, so 4 times 1 times minus 63 gives 252 all over 2 times 1 is 2. So from this, let's examine the square root. In the square root, we have minus times minus, and minus times minus gives plus. That is to say, here becomes 4 plus 252 all over 2. Alright, let's bring this to this side of the board, and we have n is equal to minus 2 plus or minus square root of 4 plus 252 5, 2, all divided by 2. N is equal to minus 2 plus or minus square root of 4 plus 2, 5, 2 gives 2, 5, 6, all divided by 2. This is equal to minus 2 plus or minus square root of 256 gives 16, all divided by 2. So at this point, there are two signs, positive or negative. So we are going to obtain two results, which are called the root of the quadratic equation. And the first result is obtained when the positive sign alone is used and the negative sign is disregarded. Again, the second root is used when the negative sign is used and the positive sign is disregarded. That is to say, to get the first root, it will become minus 2 plus 16 all divided by 2. So we are going to ignore the negative sign under and write minus 2 plus 16 divided by 2. Or then we disregard the positive sign and use just the negative sign to obtain the second root, which is minus 2 minus 16 all divided by 2 minus 2 minus 16 all divided by 2. Okay, from the first root, let's evaluate this. Minus 2 plus 16 is the same as 16 minus 2, which gives 14. And 14 divided by 2 gives 7. 7 or minus 2 minus 16 is minus 18. And minus 18 divided by 2 gives minus 9. Therefore, the root of the equation or the solution to this problem is n is either 7 or n is either minus 9. If we substitute this, 124 in base 2 is equal to 232 in base 5, we are going to obtain the right hand side equals the left hand side. This is very simple.